All right, hello everyone. I'm Junade. I always joke to myself that it's easier to speak in front of a larger audience and say a few dozen of your colleagues, but given there's a scattering of Cloudflare employees here, I've kind of got the worst of both worlds. So hopefully should go well. In essence, what I'm going to talk to you about is something kind of unique we built within Cloudflare to resolve a few different issues. So by background, I kind of worked as initially a software developer, then I worked on kind of high reliability systems for a period of time. I was doing my master's at the same time. When I joined Cloudflare, I was kind of burnt out. So till about January last year, I kind of worked in developer community. And then eventually, I decided to go back into running engineering teams. And at Cloudflare, the kind of opportunity came up to do something quite special. So contrary to popular belief, or what you might first think when you think about support operations engineering, this isn't what we do. Instead, there are a bunch of really interesting challenges at Cloudflare. So used by over 20 million web properties, variety of range of services. Support, for instance, is actually offered at a free level of service all the way up to enterprise. We have at-risk public interest groups, very, very big growing demand for our technical support organization. This involves things like, mitigating DDoS attacks for customers, very sophisticated stuff around your infrastructure. We kind of sit at the layer between your infrastructure and your customer, and therefore we have a kind of wide variety of quite tough problems to deal with there. So when I started, there's kind of the initial service you end up building, which I think a lot of you may already have built out. Is effectively, if you're working in developer products, you'll end up building a kind of, hopefully a diagnostic API of sorts. You'll go through and you'll identify the top problems of your customers, in essence. And you'll be able to automate that. And for us, the big thing was hooking into lots and lots of internal data sources in Cloudflare. And then you can expose that through various forms. So for instance, customers are submitting a support ticket. Or another instance we did was we joined with our marketing team. So this was when Chrome 68 came out. And if you remember the secure marker in the browser, basically, if there's a HTTP site, so it was never HTTPS, it would be explicitly marked as not secure. And we kind of worked with our marketing team and said, reducing your churn rate for, say, our self-serve customers, what if we actively started doing these diagnostics into the run-up? It would reduce support load, to an extent, but obviously most customers who have issues would never write in. So we started in effect doing this. It decreased our support load, but the remarkable difference was actually for our growth teams, our marketing teams were able to lower the business churn rate in the run-up to that. And actually, over that period, we had no real increase in support load. Now, the need for automation. This is something I'd ordinarily reserve as a footnote, but I think it's relevant in this context. Customer tooling is obviously better than agent tooling, but tooling isn't automation. For our customers, they ideally don't want to contact us, and there is a big amount of time that's spent, even if a human needs to push a button. But there are problems, in essence, when you deal with a support context. For example, the state of the art in natural language processing, about 70 to 80% accuracy. That is when you look at instances like, so if you were to look at very academic examples with very kind of structured tests. Before I set up this team, they looked for a commercial proof of concept with a large vendor. They could only manage 50% on our data set. And the tolerances actually for false positives vary. It depends really about what you're talking about. Is it a top-tier enterprise customer? Is it a sensitive issue which we'd need to make configuration change? Or is it just a free customer who, if we were to if the balance of probability is we can avoid them having to talk to a human, that would be beneficial so they don't have to wait as long. And this is kind of something often, my current PhD advisor, he often says to me when we talk about machine learning, it's often like describing someone, hitting a hammer in with hitting in a screw with a hammer almost. You get these instances of people who are just applying these algorithms blindly, and in essence, they aren't optimally used. So one of the earlier things I did in terms of this is we developed very different pipelines. I'll go into how these are developed. But in essence, the core pipeline is we have something named name entity recognition in order to remove kind of things like email footers and those things, kind of multi-classifier. I'll go into how we've optimized that. Then there are two elements of safety we have put in. One is designed on kind of an over-engineered principle, and the other is based on formal contracts, depending on where the risk sensitivity lies. So for example, false positive rate for over-engineering, we're able to get it down to 1 or 2%. In reality nowadays, that's a fraction of a percent. For formal contracts, it's 0%, as they're formally proved. And in order to do this, there are a few kind of novel approaches we developed. So for the baseline, failure is tolerable because the majority benefit, lower wait times. If it's an incorrect answer, they can just, they can just respond back and they'll get through to a human depending on when they can. We have a binary classifier, which is, it still maintains, so it's for higher risk customers, those who are paying, but it isn't as sensitive. And then for sensitive requests where customers would, have configuration changes which we have to make, but we'd want to automate, we have formally defined safety checks, and I'll describe how that works in a bit. So initially on our multi-classifier approach, the earlier thing I did, we hired our first kind of engineer. Now I realized there was actually quite fundamental problems we needed to solve. So I actually hired from someone who had finished her PhD. She was working on the Large Hadron Collider at CERN. Got her to look through a lot of the fundamental literature on a bunch of different things. This here is an example of string similarity algorithms. And for instance, most people end up blindly using the Levenstein algorithm to edit distance. And we actually were able to show, for instance, here, the cosine algorithm with an n-gram size of 2 was better suited, and we did this in multiple different areas. In terms of over-engineering, what we did is behind a multi-classifier, we introduced a binary classifier, a good-bad classifier in essence. The iteration time on this is lower, but in effect, we use cascading failure to our benefit. If something doesn't pass both gates, we won't touch it. In essence, this is one of the kind of things we're able to identify. It's not just about getting a best guess to a customer, it's about assessing how good it is. So here's an example of the statistics on this. If we look at, say, cosine algorithm, on either of them, you can see when we add that tactic in, we're able to get dramatically lower false positive rates. Formally defined runtime contracts. So this is interesting. There's certain areas which are particularly sensitive for our customers. And we need to be able to validate these configuration changes before we make them, but we still want them to be automated. In order to do this, this was kind of a strategy I kind of learned when I was in doing high integrity engineering. We effectively use kind of design by contract, but in a runtime setting, instead of needing to formally verify what we're actually doing before a piece of software is built, we actually have every kind of downstream API validate this. If there is a failure, the result field is effectively blank, and as a result of that, even if there was a miss in safety, these things don't fail. For some of the very kind of sensitive things, we will have these built into formally verified software. And there's bunches of ways where there are expected failure conditions where we can track and we can automate, unexpected failures where we ring off alarm bells and things if they end up failing, reversing changes and so on. a bunch of other things we had in order to complement this and provide taxonomy, classification to fill in the gaps, filling in the loop with our engineering team so everything was made self-serve. If there's a customer which writes in about something which should be self-serve, it's tagged to a JIRA, so it's nagged to the engineers. And this is kind of, I guess, an example for a particular error of how this would work in reality there. So the final thing I really want to talk about is where this goes to the very top grade of our customers in terms of security operations center. In terms of when customers get attacked, if there is, say, product misconfiguration and the attack were to come through, if it's a particularly sophisticated attack, that's something where we would want to be able to, as quickly as possible, inform the customer. And in essence, in order to do this, this is where the product fails from an attack mitigation perspective. And we need to be proactive in this. We don't want customers to go down. We want to inform them as quickly as possible, but in essence, where the product has effectively not been able to mitigate some form of attack. So this is a very simple kind of graph of something you've probably seen before. If you So along the x-axis, you've got the number of requests. Along the y, you've got the rate of errors. Effectively, on the left, the ones in red, they indicate kind of data we know to be attack traffic. On the right, just adding 2 extra dimensions of data in 4 dimensions, you kind of get a degree of clearer visibility. But we go beyond this in a lot of different other realms. For instance, for some examples of politically sensitive customers where they won't actually get too many requests, and maybe their origin infrastructure is more liable to errors, is how we differentiate between what's going on. So on the left here, you'll see 5XX, and then on the y-axis, you'll see 499. So 499 is where the client disconnects before a request can be completed. But where there is an attack, you see a kind of linear correlation. So we're able to differentiate between kind of what's going on and before a support engineer or security operations center engineer, before they kind of, or when they see their page, they can actually understand, okay, this is what we think is actually going on, and they have the data in front of them to do that. On the right, you can see another kind of tactic we use to get these things into multiple dimensions. So that's kind of DDoS attacks, but I want to talk about something else, which is around more sophisticated kind of credential stuffing attacks and how we're able to fingerprint them in aggregate. So 2 charts here. This is effectively a credential stuffing attack. There is a success ratio on the y-axis for both sides. Along the x-axis, one is, the amount of zones. So this is an example of a very sophisticated attack that is going on throughout our network. On the right, something we define as a variety ratio, which is abnormal status codes. It indicates things like rate limiting or other form of behavior where a request is causing the origin to behave in a different way. So along these 2 charts, you see the clusters. But what we were actually able to do is in 3-dimensional space here with these features, we're able to apply kind of unsupervised clusterization. And we're able to correlate to fingerprint these attacks. So for example, cluster 1, this was one of the highest success ratios, it's 30.5%, which is substantial. The most successful credential stuffing kind of bot seen definitely, throughout our network. In this instance, with the unsupervised learning, despite it being based on these aggregate characteristics, 99.5% came from the same user agent, 99.45% from the same country. And this tactic works well in other circumstances in order for us to be able to fingerprint attacks where they are working in a strategy where they're potentially doing stuff where it isn't easy to base on a single fingerprint. In aggregate and using characteristics like this, we're able to identify them and we're able to basically disrupt these types of attacks, and we're able to use this to protect particularly our highest grade enterprise customers from these when they come under these types of attacks. So in the current state, I've skipped over a lot of the stuff in between we've worked on, but the fundamental service of what we call HelperBot, which is where we apply support operations engineering in our customer support context. Services vary, things like chatbots for the dashboard to anomaly detection for high-risk customers, including public interest groups. There are about 10 of these services now, there's 6 services, sorry, and then there's 10 ancillary services which are outside kind of the core HelperBot environment but help us provision these supports. So from the starting point, ticket submission form, for free deflection, we got 57.3%, which is decent, and then HelperBot helps deflect more, and then up the plans, more and more are deflected as well for customers, and 78% without human interaction. There's plenty more for us to do. Across the board, we're only about a quarter of the stuff we work on is completely automated, and we kind of, by the end of next quarter, we want to get this up to 35%. And the key here is laying the groundwork for ever greater automation. So, for all of you, what did we learn from this? This was something, as far as we can see, hasn't really been done before. A bunch of different principles which came out. The first was favoring automation over tooling. There are a bunch of reasons for this. There's the efficiency point. There's also, it's actually, when automation is built into the pipeline, for say, companies like Cloudflare, we have a very, very technical group of technical support engineers. And the diversity of tooling and things like that, if we're able to move these to automations, it kind of mitigates the need for people to need to build that, and it removes a lot of the need for people to unify. Questioning the fundamentals. This was something we learned earlier on, the state of the art of where things are. There is still lots of research that needs to be done into these different areas. Context-sensitive safety. Safety really depends on the context it's applied in. And that's something we're quite diligent about. So there's reliability practices built into our core services, but in essence, how we provision them, that is where the context is important. In terms of being data-driven, that was essential, but it was vital for us to kind of lay the framework for that. There are multiple kind of gates we had to pass through in order to get to that point. We had to be able to get access to data internally. We had to then, after we've built up this infrastructure, it's all about how we analyze it. There's then about questioning the strategies we use to do that. At each stage, we had to build our services as an asset. Each system we built, we had to make sure it had underlying value and wasn't just lines of code in essence. So I will thank you for listening to me. And if you want to publicly humiliate me, I hope we've got time for questions. But thank you. Yeah.
Hi, you mentioned attacks and figuring out where an attack is coming from. So say you have a range of 5 different IPs, and how do you decide whether or not to ban or rate limit more aggressively? How do you mitigate those attacks? Is that automated, or is it still human driven?
So in terms of how things work at Cloudflare, there's product level mitigations which work at the network and kind of centralized as well, which feed out rules to the network. They have different reaction times. Those types of mitigation, for instance, they're controlled by a product team. They'll look at a whole different thing, look at the configuration a customer has applied. For the Security Operations Center, it really comes down to where our customers want us to draw the line, and when we onboard them, they'll be explicit about what configuration changes we can make on their behalf, and the level of control there. So it's kind of tailored to what the customers desire in that sense.
Cool, thanks.
Hi. So when you built kind of the automation tools to kind of resolve some of these issues automatically, did your engineering team have to work with all of the other product teams to kind of get some API endpoints stood up for you to interact with, or did you go directly to like their data sources and kind of manipulate the data yourself? And then kind of following on from that question, if you did work with the teams to stand up endpoints, how did you work with like the product owners to kind of get this work prioritized?
Yes. So in essence, there are two different components we have. There's one where we almost have to get access to configuration data, and that's kind of key when we want to work out how something is working to do diagnostics, and then there's a diagnostics layer. For instance, if someone has DNS issues, automatically diagnosing those. We kind of control fully the diagnostics layer, and getting access to data, it's usually about working with the product teams to get the access there. Fortunately, at Cloudflare, usually, in terms of that, things are quite liberal. We're able to build on abstractions to get the data into how we want. We don't currently have a unified supportability interface, which would be nice for product teams to implement. Fundamentally, I think the way of getting product teams into it is actually for them to realize a business impact of them not, in effect, being able to provide that level of access. It degrades the level of quality of service we're able to do. If we, again, automatically tag those to JIRA issues, and then they see, this JIRA issue is linked to, 200 different tickets because the support team haven't been able to automate this, or because they haven't serviced that configuration change in product, that gives them a very, very clear interface. Actually, one of the things the engineering team kind of drive is there's something called the EngSup board. And this is like by the amount of support tickets associated to a JIRA, those things get prioritized, and then the engineering team will make sure that work is effectively prioritized in that. I think, are we out of time or? All right, one more question.
Yeah. No? Okay, thank you so much.
All right, thank you.